Today I am going to talk about the composable function and the properties of composable function. Composable functions and properties of composable function, or I can say composable function and its properties. Okay, so what is composable function? Composable function, it is the atomic building block of Jetpack Compose. It is the atomic building block of Jetpack Compose. So, uh, so basically, we use it to construct the composable tree. We use it to construct composable tree. I intentionally say tree since the uh, function composable function can be understood as node in larger tree. So uh, so so when we execute the composable functions, basically it tells the compiler, composable functions, it tells the compiler that the function intends that this function intends to convert some data into a node and register it in the composable tree. So basically, when the composable functions gets executed, it emits an action. It emits an action to register a node in the composable tree. Okay, so the composable functions, they can also replace or remove the node, and the composable function can also read or write from or to the composable tree. So this is about the composable functions. Now let's talk about the properties of composable function. Properties of composable function. So when we write at the rate composable functions, the relevant implications when we write at the rate composable functions, relevant implication or consequences. When we write at that composable function, it imposes some constraint. It imposes some constraint or additional properties to composable function. So the compose runtime expects the compose runtime expect composable functions to comply to the mentioned properties. So the compose runtime expects the composable functions to have to composable functions are in accordance with the request or uh, uh, or or to comply to the mentioned properties, so that the compose runtime can exploit the compose runtime can exploit the optimization, uh, like the recomposition or recomposition, smart recomposition, all those things. So one of uh, one of these one of one of the things that are added to the composable function is composer. Composer is added at the end of the parameter list. So uh, so the Kotlin compose compiler, so the compose compiler plugin has the access to the composable functions during compilations, and it transform the composable functions to the intermediate representations in order to add some extra parameter. And these extra parameter are agnostic of the these extra parameter are agnostic these extra parameter are uh, agnostic of the developers who write the code. Okay. So this composer object is passed, or this composer object is forwarded to all the children composables down the tree. Okay. So the what is composer object? Composer object, it is a connection uh, between the composables code that we write and the compose and the compose runtime. So when the state when the state when the states gets changed, it uses it will the composable function will use it and update those changes to the composable tree. So that is the main purpose of the composer object. And the next parameter and the next properties of the composable function is the idempotent. So the composable functions are considered to be idempotent. Idempotent means re-execute uh, re-execute the composable function multiple times with the same input parameter will produces the same uh, UI will produces the same composable tree or the same result, we can say. So the idempotent means executing or re-executing the composable functions with the same input parameter will produce the same result. And the third properties is the side effect. So what are side effects? So in composable functions, there is any action that uh, that escapes the control of function is known as side effect. Let's take an example of calling a network call inside the composable function. So uh, we all know that the composable functions gets re-executed multiple times when the state gets changes, and this network call and this will be called multiple times, and when the composable leave the compositions, we do not have any chance to cancel this network call. So this is called the side effects. And the fourth one is the positional memoization. Positional memoization, it is the representation of like the functional representation of functional memoization. So positional memoization gives gives the ability uh, to a function to cache it result uh, result based on the function name and its parameter, so that it so that it does not execute that function again and again for the same input. Okay, so in composable functions, it uses an additional property. In composable functions, it uses an additional property, and the composable functions have the uh, composable functions has the access to the location where it is called. So it uses an additional property, uh, location of call site, location of call site plus some other parameters like the function's name and its parameter to create a unique identifier of a function. So suppose uh, at the rate composable function test, and we write three text with the same parameter like the empty text. So it will create three unique ID. The same name, the function name is same, the parameter is same, but the call site is different, so it will create three different unique IDs, 1 2 3. But this works well or nicely, uh, this works well or nicely, uh, mm, uh, but what if uh, we create what if we create what if we write the composable functions inside the loop. Suppose I is equal to 0 to 10, and then the call site is also the same, the function is same, and the suppose the parameter is also same. So it relies then the compose runtime relies on the order of the call to create a unique ID. So this also works well, but what if this also works well or nicely if we suppose in the lazy column we add some new element at the end, so all the rest of the element has the same position, so it will not re-execute those composables. But what if we insert a new element at the middle of the list? If we insert at the middle of the list, then the compose runtime will re-execute all the composables uh, below that position, because the position has changed for all the compositions below that, but uh, the input parameter has not changed. So that is not efficient. uh, so the compose provides a key, so the compose provides a way to mention the key for each composable in the lazy column. So whenever we add some new element in the middle of the list, it will check the key, and if it has the same key and the parameters, then it will not recompose those composables. So these are some basic properties of composable functions, uh, like the calling, context, restartable. Like the compose can be restarted or the recompose multiple times based on the states, and the side effect, and the positional memoization. So these are some properties. Thank you.